So your cat needs to travel at least 40 miles today, and it has less than 10 hours to make the trip. The cat can ride a Roomba for part of the trip, and that goes 5 miles per hour. And it can also ride a unicycle for another part of the trip at 8 miles per hour. Graph a system of inequalities that shows the possible combinations of Roomba and unicycle use for your cat. Okay, I'd like you to pause the video and see if you can come up with the inequalities that would go with this. Consider whether or not either of your variables can be negative, because that will imply some hidden inequalities. Okay, assuming you paused and you are back, I'll go ahead and walk through how I would think about this. So I'm going to make a table because I have noticed that, zoom back out a little bit so I can access tables. I have noticed that setting up a table helps a lot with creating our inequalities or our equations. So we have a few different situations to deal with. We have the hours for the trip, and we have the miles for the trip. Okay, the hours we know have to be, let's see. So it has your cat has less than 10 hours to make the trip. So we need to have a less than 10. So that's the total hours. Okay. Now, some number of hours are on the Roomba and some number of hours are on the unicycle. I'll use R for Roomba and U for unicycle. And that's the simple sum of hours equation. Now, miles for the trip, we know it has something to do with 40 miles. So we have another inequality going on here. It says at least 40 miles. So the lowest number could be 40 miles, but it could be more than 40 miles if the cat travels. So that means we're going to use an inequality, a greater than or equal to inequality. So I'm going to go here and say greater than, and it gives me my options. Okay, so I've got greater than or equal to 40 miles. Okay, so if your cat goes on the Roomba for our number of hours, how far is it going for that part? Well, it goes 5 miles per hour, and rate times time gets you a distance. So our rate times time is going to be 5 miles per hour times our number of hours. We can do the same thing for the unicycle. It goes 8 miles per hour times U hours. So the sum of 5R and 8U is going to be greater than or equal to 40 miles. Okay, I asked you to consider whether or not any of the variables could be negative. And as you can see, we got hours on the Roomba and hours on the unicycle. They can't be negative. So I'm going to put another row here, other inequalities. Well, R has to be greater than or equal to 0. So I'm going to go over here and copy that greater than or equal to symbol. And U has to be greater than or equal to 0 as well. So now I have 4 inequalities. Now I'm going to take this stuff and I'm going to copy it down here as equations, or inequalities, I should say. R plus U is less than 10. 5R plus 8U is greater than or equal to 40. And we also have R is greater than or equal to 0, and U is greater than or equal to 0. So those are our 4 inequalities. Now, at this point, a few of you have written me and said, but Mr. Ward, how do I deal with more than 2 inequalities? Well, you're just going to need to graph each of the inequalities and see where all of them overlap. You just need to pay attention to what the overlap zone is that all of the inequalities share. So let's start with the really easy ones. These two are super easy to graph. So r is greater than or equal to 0. I'm going to change my variables right now because I'm going to go into Desmos. So I'm going to want to be able to use variables that work in Desmos. I'm going to change r to x. So I'm going to copy all of these inequalities, and I'm going to change r to x and u to y. And everywhere I have r, I'm going to make it x. And everywhere I have u, I'm going to make it y. And there I have my inequalities in a form that'll work for Desmos. So these two are really simple. If x is greater than or equal to 0 and y is greater than or equal to 0, then I'm dealing with the first quadrant of my graph. So let's go over into Desmos. What that means is if x is everything over here and y can only be up here. So I have an inequality right now of x is greater than or equal to 0 and y is greater than or equal to 0 as well. And so I have just this quadrant to deal with. All right. So I'm going to move my graph over just a little bit. Now here I have my other inequalities. This is my simple one. This is in standard form. My coefficients are 1 and 1. And if I make x equal to 0, so first of all, graphing inequalities, just a reminder, the first thing we need to do is graph a line that's going to be a boundary line. So I'm going to use all my line graphing tools. So if x is 0, then y would be 10. So I'm going to have a y-intercept at 0, 10. Now, if y is 0, I'm going to have an x value of 10. So I'm going to have another intercept. This is my x-intercept at 10, 0. And some of you may object and say, but Mr. Ward, my graph doesn't have 10 on it. This is not precision graphing that we have to do here. So you can get away with eyeballing where those 10, 0 and 0, 10 are on your graph. Now, this is just an inequality. So these are going to be holes. They are not solid points. They are exclusive, not inclusive. So I'm going to plot them like that. And then I'll go ahead and show my labels. Then I would draw a line that goes through them. So x plus y equals 10 is the boundary line. And again, this is a dashed line. So I got to fix that. A dashed line, because this is not an or equal to inequality. Now, the last thing I need to do is figure out, is 0 plus 0 less than 10? I'm going to use 0, 0 as a test point. So I'm going to see if 0, 0 is true for this inequality. So 0 plus 0 is less than 10, so I'm going to be shading this way. So I'll go ahead and do my shading, and there I have it. So far, I have 3 inequalities overlapping. Y is positive, y is 0 or positive, x is 0 or positive, and x and y have to be contained underneath this dashed line. So I've got this little triangle zone. Now I have one more inequality to make sense of. And this is an or equal to inequality, so it's going to be a solid line. I'm going to start by graphing the boundary line. So my first step is to figure out my intercepts. So if I make y equal to 0, this 8y goes away, and I've got 5x equals 40 when I'm thinking about my line. So I have to divide both sides by 5. Okay, and then I have x equals 8. So 8, 0 is one of my intercepts. And if I do the same thing, I make x equal to 0, then I've got 8y is greater than or equal to 40. I divide both sides by 8. I get 5. So 0, 5. So now I have this inequality, these two intercepts that I can draw a line through. I'll go ahead and show the label. They are solid points because this is an or equal to inequality, and I'll go ahead and draw my line through them. 5x plus 8y equals 40. Now we got to figure out what zone is going to be shaded. So I'm going to use my usual go to of 0, 0 because this doesn't go through 0, 0. So 5 times 0 plus 8 times 0 is just 0. Is 0 greater than or equal to 40? It isn't. So I'm going to be shading that way. So I'll go ahead and do my shading. And there it is. I've got this zone. And this is 4 inequalities. I've got this zone where x is greater than or equal to 0, y is greater than or equal to 0, x plus y is less than 10, 5x plus 8y is greater than or equal to 40, and I have just this zone here that is the overlap zone. So anything along these solid lines is legit, not this dashed line, but anything in this 4 inequality overlap zone is a solution. This is the solution for my system of inequalities.